Welcome to The Architecture of Materiality Mapping the Intensive in Deleuzian Economics. Today we explore how we define and understand the building blocks of reality through the lens of intensive processes. Materiality isn't a single, uniform concept. On this slide, we contrast three distinct frameworks: reductive materialism, associated with majoritarian science, and rigid structures, non-reductive materialism, where minoritarian science highlights fluid, intensive dynamics, and expressive materialism, where postmodern philosophy views materiality through qualitative conceptual fields. The intensive serves as our bridge, a vital criterion for understanding how we move between quantitative and qualitative thinking. How do we categorize the nature of being? When force and matter individualize into a single body, they branch into three specific categories: the quantitative, which is measurable; the qualitative, which is defined by essence; and the intensive, which acts as the dynamic threshold between the two. Let's compare these three. Quantitative entities are easily articulated, divided, or combined without changing their nature. Qualitative entities, however, resist articulation. You cannot divide a color or taste. The intensive occupies a unique middle ground. While we cannot divide quality itself, we can certainly categorize it by measuring its intensity, providing a bridge between these states. In our first experiment, we look at quantitative articulation. Imagine a large, uniform cube. If we divide it, the resulting pieces maintain their exact nature and properties. This is the hallmark of extensive properties. Quantity changes, but the identity of the material remains constant. Contrast that with qualitative articulation. If we attempt to divide a qualitative entity, the attempt fails; it remains whole. You cannot divide a pure quality. However, as shown here, we can categorize qualities like varying shades or intensities even if the underlying quality itself remains indivisible. Intensive properties behave differently. In this experiment, whether we divide a substance or synthesize identical states, the temperature remains constant. The intensive value is independent of the quantity of matter, unlike extensive properties which would scale with division. However, when different intensive entities meet, we witness emergent characteristics. Mixing a substance at 50 degrees with one at 100 degrees doesn't just add them up; they interact to minimize differences, resulting in a new, averaged state. Here, the nature of the entity inevitably changes. Intensity is defined by the ability to generate change. While an inert, qualitative state sits at static equilibrium with no potential difference, an intensive generator creates a flow. As Manuel de Landa notes, it is the difference in intensity that drives the movement of matter and energy. We define the intensive boundary as the critical space where the molar, our quantitative and qualitative world, meets the molecular. It is the transition point between the rigid, measurable structures of majoritarian science and the fluid, generative forces favored by postmodern philosophy. This brings us to two levels of abstraction. Molar abstraction views systems as stable, inert, and quantifiable fixed points in space. Molecular abstraction looks deeper at self-organization, emergent properties, and intensive flows. Both originate from the same reality, simply observed at different resolutions. Thermodynamics and statistical mechanics are prime examples of molar abstraction. By capturing intensity and fixing it into values like temperature, pressure, and volume, we turn dynamic processes into measurable, static data. Conversely, molecular abstraction seeks the genesis of being. By studying forces and differentiators in complexity science, we look past quantified states to understand the underlying drivers of self-organized criticality. In summary, materiality is a transition. The intensive acts as the active, emergent threshold where molecular forces differentiate and stabilize into the molar realities of quantity and quality. By mapping this architecture, we gain a deeper understanding of how the world structures itself.